Hello and welcome back, or welcome if you're a new viewer. Today I am going to embark on a little project here with the help of my 1959 RCA receiving tube manual, which unfortunately is getting a little bit the worse for wear. I think I've got to look for another copy of that. My 1942, is it? 1941 Radiotron Designer's Handbook. This was a book put out by RCA on vacuum tube design. My 1946 Radio Amateur's Handbook, which also is a little bit the worse for wear, but a wonderful resource when you're working with vacuum tube equipment. And hopefully some input from my viewers. What I'm about to do is build an AM transmitter designed to take a phonograph input and play back, or to play back, through my antique radios. I've also purchased a transistorized kit, and after I purchased the kit I said, why don't I just bite the bullet and make one out of vacuum tubes? I've got some of these wonderful 6L6s, the Coke bottle style, beautiful old tubes, just absolutely beautiful. We've got ourselves a 5U4 rectifier. I've also got some 5Y3s, and I've got some, I've got a plethora of full wave rectifiers. In fact, I'm going to have to move the power transformer because the fins on the transformer are interfering with that, but that's okay. I may end up burying a 12AX7 down inside. I wouldn't want to put this on the top and interfere with the classic look of these older vacuum tubes, but I may need for my magnetic cartridge a preamplifier. And then that got me to thinking, I have some of these wonderful old 6N6s. These are dual triodes. There's a preamp slash driver section, and then there's a power amplifier section. These are not as powerful as the 6L6. I think the 6L6 class AB1, you can probably get about, I don't know, 6-7 watts out of them. I think this tube is good for 1 or 2 watts, class A. And I think the 6L6 itself on pure class A is only good for a couple of watts. So that would be an interesting tube to use. I have 4 of those that are in excellent condition. And I just haven't made my mind up yet. This chassis was a power supply at one time. One of many that I built way back in the day. And I have no recollection what I built it for. It is marked here 6 volts, 150 volts, and 300 volts DC. And I really don't know what I built it for. It's obviously got a dual section filter with a choke. I haven't even taken the bottom off of this in years. The bottom, that's a note when I loaned it to a buddy of mine so that it wouldn't get mixed up. But the bottom panel I made years ago when I was working in the precision sheet metal trades shortly after I got out of the Army. I have no idea what the original chassis was from. I believe the power transformer is probably from a Heathkit television. I know I stripped a couple of those for components, and I seem to remember some of the Heathkit color televisions had these finned power transformers. I don't know that for sure. That's just supposition. I think if I clean this up and polish it up, and I've done a little bit of a test on the back, and probably can see it's going to clean up quite nicely. There's a little bit of rust around here, not a lot. I'll put a little naval jelly on there and then clean this up. I've got holes here for phono inputs, for the modulation pot, yada yada. What I had started out doing was I watched one of Buzz 1151's video, and he had a Packard Bell phonograph with a built-in AM transmitter, and it was based pretty much on this schematic. I couldn't read the component values. I could see the schematic well enough to figure out what was going on. We've got an oscillator, 6L6, that's the RF oscillator. We have a 6L6 to modulate it. And this is shunt modulation, or Heising modulation. Now this doesn't have the Heising choke, or the modulation choke. This is just using a resistor. The way this thing works is the B plus runs through this resistor, and both of these tubes are biased class A. So they're both drawing an equal amount of current. These are also called constant current modulators. And what happens as the audio waveform rises, as you start to draw current here, it causes a drop in the resistor and lowers the output of this 6L6, the RF oscillator. And the reverse happens as the sine wave drops off on the audio, stops drawing current, the RF power, the current is available for the 6L6. And in theory, these two equalize, their current equalizes. As the 6L6 draws the current down, there's a shift in the current. As it draws current here, less current's drawn here. As less current's drawn here, more current's drawn here. Theoretically, it balances, and that's why it's called a constant current modulator. I don't know how good these circuits are. I suspect this is probably only good for about 20 or 30% modulation. Then I said, what the heck, why don't I just put a small modulation transformer in here and build a plate modulated transmitter of a watt or two? Yes, that exceeds the FCC limits. I will be limiting the power out to the antenna so that I won't transmit any further than my yard or maybe halfway across my neighbor's yard. I'll keep the power level down so there's no reason for Uncle Sam to come knocking on my door. At any rate, I priced modulation transformers and almost swallowed my tongue. Even a small 10-watt modulation transformer, which is more than enough for this circuit. I'm only going to need a couple of watts. Small modulation transformers starting around $80 and just skyrocketing after that. And I said, I'm trying to do this out of my junk box. So I'm probably going to fall back on this circuit here or something like this. Now I dropped Buzz1151 a comment asking if he could take another video of this with better lighting so that I could capture all the component values. It would save me a lot of time in design. The tank circuit's real easy to figure out. I don't need anything there, but it'd be nice to know the component values they used to initially set this for Class A operation. He didn't answer, and I wasn't that surprised because when you have a lot of subscribers, you can't get to all of your comments. Some guys just stop altogether. And I'll probably have to do that myself someday if I ever get that many subscribers. Probably won't. But I understand why. I mean, you'd spend your whole day answering questions. At any rate, if anyone knows where I can get a copy of this schematic, this was a Packard Bell 42B. And I want to do some modifications on it. I know there's a way to make some improvements on it. They've only got a 4 microfarad bypass capacitor on the 6L6. And that causes voltage swings on the cathode. I think I'm going to increase that to probably 20 microfarad. And I'll play a little bit with the oscillator. I thought about doing crystal control instead of having it just, an RC or an LC circuit here. LC circuit. But I said, no, I'm going to stay old school. I'm going to leave. I'll just use a quality cap. I'll wind my coil, pick off my tap for my cathode bias. I'll figure all that out. That won't be a big deal. But I'm looking for ideas. Anybody have any ideas out there? Anybody have any experience with these? Any pitfalls that you know about? I'd be interested in hearing about them. I may or may not use whatever suggestions you have. But it'll be interesting to get some feedback and see what you think. When this is all done, I'll have a phonograph input. I might do one for both a ceramic cartridge and a magnetic cartridge. I have a magnetic cartridge in my my turntable that I repaired on one of my previous videos. And it'll be interesting to see what kind of sound quality I can get out of this, and how much modulation I can get. If I can get this thing up to 50-60% modulation without distortion, it should work out pretty well. I'll just build a standard full wave rectifier. Originally this circuit had a 35L6, a 35, I think it was a 35X4 rectifier, and a 50L6. So it was a 50L6, a 35, and a 35. It was series string, half wave rectifier. I want to go full wave rectifier. I don't like series string circuits. I want to be able to touch this thing safely and not have to worry about getting bit. And I just like the look of this old transformer, to be honest with you. Again, I have no idea what I originally built this for, but I'm going to repurpose it. I'm going to strip this down, polish it up, clean it up, test this capacitor. If I can reform this, I will, and I'll use it. This isn't an expensive, rare radio of any kind. I'll take the chance and use this capacitor. I'll fuse the center tap on the secondary of the transformer, so that if this goes dead short, it'll just blow the fuse on the secondary and won't burn up the rectifier or the transformer. Let's see, what else did I want to say before I disappeared here? I guess that's it for now. I'm going to start tearing this thing apart, getting it cleaned up, and I'll take you through the journey as we go. Hopefully, when I'm done, I'll have a nice little phonograph, phonograph transmitter, so I can play my records and my old music through my antique radios. So, let's get started. Okay, we've got the bottom off of this thing, and I must have built this. I built so many of these I can't be sure. I either built this before I went in the Army or shortly after I got out, and this would have been many years ago. I seem to remember this little insulator came from another defunct oscilloscope, one of those training scopes from either DeVry Institute or something of that ilk. I can't guarantee that, but I seem to remember this, and it's got handwritten numbering on here, like it's definitely from a kit, and it's not my penmanship. It's way too neat to be mine. It's got some fairly decent resistors in here. I seem to remember this was a regulated supply for something, and it probably had a 6L6 pass tube here. I don't really know for sure. The only thing that's written on the top is 5U4 or 5Y3, excuse me. 5Y3 was the rectifier I used. I did mark all the lines at the time. That says rectifier filament. That says 6.3. This says primary. I imagine underneath here there's one that says secondary. Look at these beautiful old rectifiers. That's what came out of my junk box at the time. It was probably scrounged from some piece of equipment. I did fuse it, although the fuse holder doesn't fit the fuse, or the fuse is too long for the fuse holder. It's probably all I had in my junk box at the time, but at least I fused it. Put a little indicator lamp. I love that old indicator lamp. And I don't know, let's see, that says 150 volts on, no, that's the common? No, that's 6 volts. Oh, where does this go? I don't know. I'm not even going to try to figure this out. I'm going to take it apart, clean up the chassis, and rewire this thing. I'm going to move the transformer over so I can use this beautiful, beautiful 5U4. I love those tubes that look, these Coke bottle design. These are great old tubes. So I'll have that room for the 5U4 rectifier. If I move the transformer just slightly, see if I can reform this capacitor. I'll do that slowly over a couple of days. I'll tie all of these terminals together. I'll start out and I'll let it soak on 24 volts for 48 hours or so, and then start sneaking it up. I think that's a 450 volt rated cap. My power supplies are current limited, so if the capacitor goes full short circuit, it won't hurt anything. It'll just go into current limit. So I'll turn that on and let that thing reform. 24 volts I'll start with, then I'll take it up to like 48 or 50 volts, let it soak for 48 hours, and then I'll bring it up to like 100 volts and let it soak for another, I don't know, 24 hours or so. And if it's looking good, then I'll bring it up to like 300 volts, near its rated voltage, and let it sit for a day and make sure it's going to be okay. If it makes it through that test, I'll feel safe using it. And I'm seeing also numbers in here. I'm wondering if this was part of the oscilloscope. This may have been. In fact, I do know where this came from looking at it now, because the handwriting on the numbers under here is the same as the handwriting on this. This was the chassis. I remember now. This was the chassis for my first oscilloscope that I got out of the junk bin. This had a front panel that came up to here and then sloped back about here. There was a 1-inch CRT. This had a 1-inch cathode ray tube. It had no trigger. It was just free running sweep. It had absolutely no graduation. There was just potentiometers. There was no retrace blanking on this, nothing. And it wasn't even linear. If you put a steady tone like a sine wave into it, a tone into it, the sine wave would start out very closely spaced and then spread out towards the end of the tube over a 1-inch tube. So that tells you how bad the linearity on this thing was. But looking at this now, I do remember there were inputs on the side, or were they inputs or outputs? This was designed to work with some other piece of equipment in the training series, so they used the power supply, the original power supply. This is not the original transformer. The original transformer was much smaller. You can see the bolt pattern in here. So I do, now that I look at this underneath and realize that the handwriting on these numbers is the same as this card. This was that training oscilloscope, and it wasn't DeVry. I cannot remember the name of the school this came from, but it was one of those scopes from either the late 40s or the very early 50s. So I'm going to strip this thing down and start cleaning. And here we have it. We have a pile of parts, a filter choke, which I will probably reuse, several tube sockets. I do have some other tube sockets here that I could possibly use. They're probably a little bit better quality. Try to make them match this style if possible. Although these are probably the original tube sockets that were with this chassis in the beginning. I went through my pile of power transformers. While this is a great looking transformer, and this is not the Heathkit. This says Motorola on it, I just noticed. So I did find a Heathkit transformer in my pile of transformers. I've got probably 20 or 25 old power transformers in a drawer. The Heathkit transformer, the whole transformer is the size of this. I mean, the core is massive, and it says Heathkit on it, so I don't know what that came from. I found this transformer, which could possibly be the original, although I do not see anywhere on here. Let's see, I don't know what that is. I don't see any marks on here that match these holes. Well, maybe there is faintly there. I don't know. This could be the original, or it may just happen to be the same form factor and fits in the hole. I'm going to measure the secondary on this. I think this is probably going to be the one I use, because it will bolt right in with, I don't think, any modifications. I think it will fit. Yes, that looks like it's going to fit in the hole. I'll have to try it. I'll have to take these screws out and see if it actually fits. Doesn't matter. I'm going to do that off camera. We'll clean this up. I had put this filter capacitor in here. This was not original to the chassis, and I can tell from the burr that I did this with a Greenlee punch at some point. These original factory holes have no burrs on them. They were deburred before the sheet metal was formed. This has a burr in the upwards direction. I can tell by looking at this. Years of experience. These were punched in a downward direction in a punch press and then deburred before it was formed. This, the burr is up, which means I did it with a Greenlee punch and soldered the capacitor in. With a little work, I got it out. It makes it easier to clean the chassis up. I thought about leaving it in, but I figured I'd clean everything up, get it all polished up. We have the base that I built at some point in time. I know I built that. I recognize the PEM nuts and the construction. That's something I did back in the sheet metal shop. That would have been early, very early 1970s. So this has been around for a while. We have a pile of reusable parts. I'll reuse a terminal strip for something on the side of this. I have a fuse holder. I'm going to save this indicator lamp. I love this lamp, but looking at this, I see paper stuffed inside, or something is stuffed inside. I probably rebuilt this at some point and changed the lamp, and obviously I went too high in the wattage. You can see it's melted it. You know, early days. I will probably take this apart and convert it to LED. But I still want to use that. It's just such a classic piece. This is going to look great when it's done. I'll even polish this up, clean it up and polish it up. Now this is an interesting cap. 100 microfarad at 400 volts, 230s at 400 volts, and a 10 microfarad at 400 volts. We're going to start that cooking tonight on the current regulated supply. I won't even bother testing it until I've done that. I'm not going to do an ESR check on this until I've at least run it overnight on 24 volts to reform the electrolyte at least a little bit. So there you have it. We're going to start. We're probably going to go with the constant current design for the time being. I will keep looking around for an inexpensive small modulation transformer, something that's good for, you know, 4, 5, 6 watts and designed for, I think these tubes are designed to run into an impedance of about 5,000 or 6,000 ohms. So I'll have to look around. I could pull the tube manual out. We'll do some testing of the oscillator and the preamplifier for the preamplifier and amplifier for the phonograph. I can build right on here. I built these years and years ago just for doing experimenting. In fact, I had that 6N6 that I showed you, the double triode, was on here, and I did some tests and was very, very pleased with the way that tube performed. We can play around with building a preamp for the magnetic cartridge. This has probably got a 12AX, yes it does, it's got a 12AX7 already in the socket. So at some point in time I was obviously playing with preamplifiers. Very, very popular tube, high mu triode, dual triode. Okay, that's it for tonight. I'm going to get everything cleaned up. We'll get the rest of the solder off the terminal strips. We'll get the chassis polished up so that it looks presentable. We'll spray a fresh coat of black paint on this transformer. We'll get some of the rust off it. I'll probably go ahead and just build a power supply into this, and for the time being temporarily bring the power out on the side over here so that I can experiment with the oscillator design here. And when the oscillator is designed, I'll install that, and then we can go on and start working with the modulator section. That's it for tonight. I'm going to bed. I've had a whole week of 12-hour days at the normal job, and I'm beat. I'm not 30 years old anymore. I'm finally figuring that out. I'm the radio mechanic, as it says right up there. See you soon.